I don't know what to say in terms of a quick review of what we did yesterday. What we're doing is continuing to use our graphing calculator and some previous math skills to solve problems that involve quadratic functions that are in standard form. Really, that's what it boils down to. Today we're going to connect standard and vertex form together in a more meaningful way. Apparently on page 176 there were 4 problems I recommended, and on page 195 there were 4 problems. Do me a favor, take just a few seconds and look over your work. Does anybody have any questions? Go ahead, McKenna. 23B. So this is a great question from a standpoint of being able to use your math skills. And I know that you asked about B, but I'm going to do A very briefly. When you look at A, and every time we do a question like 23A, I'm going to replace f of x with y just to make more sense of it. Every time we do a question like 23A where you have y equals negative x squared plus bx plus 11, and it passes through this point, I'm hoping more and more and more of you recognize we do this problem again and again in different contexts. If you were to go back in your notes and look at sequences and series, we did problems like this where you had some number that was unknown. That number, which is b, is a missing parameter. So in order for you to find the value of it, you're going to put in x equals negative 2, which will produce y equals 1, because the graph passes through that point. Again, this is lost on us a lot of the time. What does it mean when you look at a graph and it's this curve or this line? It means that every point on that line has an x and a y value that make the equation true. It means when you put that x coordinate into the equation, you get that y coordinate. So this allows me to be careful. When you do substitution, I've always recommended make sure you put it in brackets. This allows you to solve this equation for b. I'm going to simplify this first. We have 1 equals negative 4. Be careful there, everybody. The negative 2 in brackets squared is positive 4, but there's a negative in front of it. And then we have minus 2b plus 11. So this becomes negative 2b plus 7, because negative 4 plus 11 is 7. I can move the 2b over and subtract 1 from both sides and end up with b equals 3. And you didn't have a problem with that. You got that question right. No problem. And then we get to b. And I think this is maybe a little bit important. You understand my thinking here. I could have very easily included an example like B in yesterday's lesson, but then the lesson gets too long. And I know that even if I did, somebody's going to ask about it the next day. So a lot of the learning that takes place now, right? Just because we didn't do this one yesterday doesn't mean you don't have to know how to do it. The problem here is in B, you have y equals 2x squared plus bx plus c. You have 2 missing parameters, right? You have 2 things that you have to find. And you're told, I'm going to pick on the point negative 1 comma 6 just to begin with. This means when x is negative 1 and you put x equals negative 1 in, you get 6 for y. Let me put those numbers in. I'm going to put negative 1 in for x, and I know that 6 comes out. So, and I'm also going to clean up this equation. Let's see, negative 1 squared is 1, times 2 is 2. So I have 6 equals 2 minus b plus c. You okay with that? And I'm just going to get rid of that 2 to the other side, so I end up with 4 equals negative b plus c. Now, as a mathematical hurdle, this is impossible to jump over. I cannot rearrange that for b and get a number for an answer. And I cannot solve for c. You cannot solve an equation for one variable if there's another variable. These variables are actually parameters, but you can't solve for b unless you have c and vice versa. But I know that this graph also passes through 2, 3, which means that when I put 2 in for x, I have to get 3 coming out for y. So let's simplify this. This is 3. 2 squared is 4 times 2 is 8. And then we have plus 2b plus c. I'm going to subtract 8 from both sides and get negative 5 equals 2b plus c. So what I'm getting at, and I guess I'll just reveal it in case it isn't obvious, is we have to solve a system of equations. Whenever you have two unknowns, you need two equations to find those unknowns. So any questions to that point? Okay. I'm a big fan of elimination when I solve systems of equations. It's not that I think substitution is bad where you rearrange one equation for a variable and sub in the result in the other. I just think that elimination is simpler in many cases. So for example, if I stack these two equations on top of each other, there's a number of things I can do. The one thing I notice is that both of the equations have c. So if I multiply one of the equations by -1, that equation will no longer have a c, it will have a negative c. And if I add the two equations, then the c in the one equation and the negative c in the other will cancel. Let me show you what I mean. I'm going to multiply this equation by -1. So it's going to become -4 equals positive b minus c. And now I'm going to add this equation and this equation. And if I add those two equations, I get -9 equals 3b. Oh, and I don't have any c's. So now I can divide both sides by 3, and I know that b is -3. b is -9 over 3. b is -3. So I'm halfway home. I have one of the two parameters. And in fact, I'm halfway home, but I'm really actually 90% of the way home, because now that I know what b is to find c, I just use an equation that I already have relating b and c. So for example, I might take this equation, -4 equals b minus c. I can write -4 equals -3 minus c. You know, in retrospect, I would have used the top equation. Then I wouldn't have to deal with a -c, but that's okay. I'm going to move that -c to the other side and get positive c. Then I'll have -3, and I have to add 4. Is that okay? That means c is equal to 1. And now we have the two parameters. And again, was it 2x squared? Was that what it was? Plus bx plus c? Okay. What that means is that our equation of the function is 2x squared plus bx. Now b is -3, so minus 3x plus c, which is 1. This was supposed to go through -1, 2, -1, 6, and it was also supposed to go through 2, 3. So if I go zoom standard, let's check it out. It should go through -1, 6. I can do this by going to my table, starting at 0 and going up by 1. And this allows me to scroll around. If I look at -1, it goes through 6. If I look at 2, it goes through 3. So it worked. You okay with that? Okay. Any other questions before we get started today? Yeah. Certainly. Take it you mean this 13? Okay. So the managers of a business are looking at their business. They're looking at money. They're looking at costs and revenue and profit and all this. And it says it's more cost effective for them to produce more items. I mean, think about this. If I don't know what kind of business I might start, maybe a silk screening business where I'm going to make t-shirts. It's not very cost effective for me to make 10 t-shirts a week for a lot of reasons. I mean, I have to buy ink for the silk screen in cans that are a certain size. And if I'm only making 10 t-shirts, that's an exploded cost. I have to make a frame for the silk screening. Producing a small number of items can be very expensive. And I only get back a certain amount of money per item, so I don't make a lot of money. On the other hand, and you could probably come up with your own situation here, if you produce lots of items, like 1 million items, it becomes what we call cost prohibitive. It ends up costing you so much, you have to, now all of a sudden, you know what, I can't do this in my garage. I got to rent a warehouse, right? I have all of these added costs. And someplace in between producing too few items and too many items is kind of the sweet spot, the Goldilocks zone. It's just right. And what we're asked to do is find that here. We are told that the cost to produce the number of items is described by 75 times the number squared minus 1,800 times the number plus 60,000. Now, one thing about this formula, the n in the formula, I don't believe is number of items. It is thousands of items. Okay, so we need to keep that in the back of our brain that if we ever come up with n equals 5, it's 5,000 items. Okay. The other thing to note is that this is cost. As a business owner, you want to minimize the cost, right? I think. If you don't realize that as a business owner you want to minimize the cost, then you better find a different line of work, right? When you look at this as a quadratic function, this is our y and this is our n, and since the leading coefficient is positive, this parabola opens up, which means it has a minimum cost. And this is the number of items that you need to try to produce to minimize your costs. So ultimately, this involves going to our calculator, entering in the function for the cost, 75x squared, and I don't know what I just did there. 75x squared, and I hope you understand that x is n and y is c. Minus 1,800 n, or x. Better make sure I'm entering it correctly. I know yesterday I made a mistake in entering something. Plus 60,000. I'll check it against the original question. I think it looks okay. Now this, we've done this table thing many times to explore what to put for our window settings, and I'm hoping every time we do it, it makes more and more sense. We know this is a minimum. So if I were to just start with starting at 0 and going up by 1, what does my table look like? Well, my y is going down, and I'm after the minimum. So what I could do here is continue to scroll until I see it change direction and start to go up. Now, I may have to reset or change my table settings because I maybe don't want to scroll up by 1 every time. I don't know. I'm gonna be patient here and scroll Oh yeah, it's starting to go up again. So if I found that I was scrolling and scrolling and scrolling and it's still going down, then I might go back to my table settings and start at 0 and go up by 5, or start at 0 and go up by 10. But I can see it's minimizing somewhere around 12, 13, 14, 15, 16. So I'm going to recognize that this is around, it's 13-ish. You get my drift? But I don't want to look at just half the graph. I probably want to go to, twice. I want to see that curve. The other thing I notice is that when I started off, and I'm just going to go back to my table setup and start at 0 again, and I didn't want to graph it. We'll have to wait this out. That it started off at like 60,000, which makes sense because that's the y-intercept. So putting this all together, it makes sense that I should go from 0 to about 25. Have I addressed with this class what x scale means? It's just where it puts a tick. If I have x scale equals 1, it's going to put a tick on the x-axis every 1. So we can be a little more elaborate and put 5 there. So it's going to go 5, 10, 15, 20. And here I'm going to go 0 to, 60,000. And think about that. If I leave the x scale as 1, it's going to have 60,000 ticks running up the vertical axis. So you might want to change I think I called it the x scale, but it's the y scale. You might want to change the y scale to 10,000. Then it's going to put a tick at 0, 10, 20, 30, 40, 50, 60,000. Don't ever mess with the x-res. One day I'll explain to you what it means, but it's not important. Yeah, see, that makes sense. That table is valuable in picking the window settings. There's a lot of wasted space below the minimum, but anyway, now, Butesha, we can answer the question. This is a minimum. I put my cursor to the left of the minimum. I hit enter. Put my cursor to the right of the minimum. I hit enter. I hit enter. And what I discover is that the minimum cost is 49,200. What do you want to do to get that outcome? You want to produce 12,000 items, whatever they are. Is that okay? All right, we are going to move on. If there are further questions, we can get to them later. You can ask me as I make my way around the room later. By the way, as good as I think you have all become at picking the right window settings to see it, it can still be frustrating. Yes? So today we're going to learn how you could find out where that vertex is algebraically without your calculator. Okay. Well, this particular one we might have to wait till tomorrow to learn how to do, but we'll see. So we're moving on to the next lesson here. This is section 3.3. This unit only has 3 sections in your textbook. We've covered the first one, which is the vertex form of a quadratic function. We've covered the second, which is the standard form. Now we're going to cover the third. Section 3.3 is called completing the square. So this goal that you're looking at here pretty much summarizes what completing the square is. Completing the square is a verb. It's something we do. It's an action word. What does it accomplish? Well, it accomplishes taking a standard form of a quadratic function and turning it into the vertex form. Okay. So when a quadratic function is written in vertex form, I mentioned this many times, the vertex form is rich with information. It's just overflowing with information. You can tell what the vertex of the quadratic function is by looking at it. It's at P, Q. You can tell where the axis of symmetry is. You can tell if the parabola opens up or down based on whether a is positive or negative. And you can also tell me about whether the parabola is taller or shorter, but I think you've gotten the impression from me, rightly so, that I really don't care too much about that in Math 20. It's not that big of a deal. Just you should understand if the parabola is going to be taller and narrower or shorter and wider. On the other hand, we often write a quadratic function in standard form. So instead of saying y equals a times in brackets x minus p squared, all squared, then plus q with all that information, somebody's multiplied it out and written it as y equals 2x squared minus 11x plus 3 or something. And this is called standard form. And it tells us very little about the graph of the function. I do mention in your notes, and I've mentioned this before, that we do know the value of a. That if you take a vertex form, and I'm going to do one really quickly, if I take a vertex form of y equals 2 times x minus 3 squared plus 8, and I expand this out, this means I take 2 times x minus 3 times x minus 3 plus 8. What I'm reminding you of, first of all, is x minus 3 quantity squared means x minus 3 times x minus 3. You need to FOIL it. You get y equals 2 times x squared minus 6x plus 9 plus 8. When you FOIL out x minus 3 times x minus 3, you're going to get x squared minus 3x plus 9. When I multiply that 2 through, I'm going to have y equals 2x squared minus 12x plus the 18 plus the 8. So in standard form, it's 2x squared minus 12x plus 26. Now in vertex form, this number is called a, and in standard form, this number is called a. All I'm pointing out is the a value is the same for both. Okay? Let me get to the point here. We're going to come back to it. If I was going to tell you to turn off your phone, but I believe that was my phone, and I apologize. It's clear, I hope, that based on the work I just did, these are the same, right? They're the same thing. But if I gave you this one that is highlighted, and I said, where is the vertex? You'd just go, I don't know. That's what we're doing today, learning how to go this way. That's completing the square. All right, but we have a warm-up here because I need you to understand something very important about perfect square trinomials. So we're asked to simplify all of these expressions. This is called a binomial perfect square. All of these are binomial perfect squares because they are a binomial squared. All of these are a binomial squared. That's what it means to say a binomial perfect square. So we're going to simplify them all. I'm going to just set up the first one with you and do the first one with you. And then I'll give you a minute to do the remaining ones. Don't forget that when you square a binomial, it means you take that binomial and multiply it by itself. And I know there are people in the room that don't have to write x plus 4 squared as x plus 4 times x plus 4. But I also know there are people in the room that if they don't, they'll do something wrong, like write x squared plus 16. X plus 4 times x plus 4 is x squared plus 4x plus 4x plus 16. It's x squared plus 8x plus 16. So what I would like everybody to do is I would like everybody to calculate, simplify, expand. I want you to find out what these other three binomial squares are when you square them. Pretty straightforward, really. And I would probably say that those of you that are done are the people who don't need to write x plus 4 times x plus 4. You understand what's going on here. I'm not going to do this for all of them, but if I were to write out x minus 3 times x minus 3, and I applied the FOIL rule, I would take x times x, and that gives me my x squared. I would take x times negative 3, which is negative 3x. I would take the other x times the negative 3, which gives me a second negative 3x. So I get negative 3x and negative 3x, which is where the negative 6x comes from. Excuse me. And then I have negative 3 times negative 3, which is 9. So I want you to notice that the constant term is always positive. Whether the binomial has a negative in it or not, the constant term is positive. If the binomial does have a negative, then the middle term of the trinomial has a negative. So we talk about x minus 3 quantity squared being a binomial perfect square. This is a perfect square as well. It's a perfect square trinomial. And I want to just talk about this for a second. I could just show you how to complete the square, but I think you'll be more successful if you understand at a deeper level what's going on. If I say to you, is 16 a perfect square? That's a question I'm asking you to ponder. Is 16 a perfect square? I think it's obvious the answer is yes, right? But if you say 16 is a perfect square, you'd better be willing to answer this question. What is 16 the perfect square of? That's an important question. It's the perfect square of 4, isn't it? What this means is you square 4 to get 16. So if I say to you, and you can look at your notes in the warm-up here, is x squared minus 6x plus 9 a perfect square? The answer is yes, if you can tell me what you square to get that. And the answer is yes. The answer here was yes. And here the answer is yes. It's the perfect square of x minus 3, because x minus 3 was what we squared to get it. So this is what a perfect square means. It means you can rewrite it as a thing raised to an exponent of 2. And now comes the important question, one of the most important questions in this unit. What's the relationship between B and C in the simplified form of a perfect square trinomial? So I'm asking you this. I'm going to erase some stuff here to give myself a little more room for you to think about things. And then I'm going to rephrase the question for you. In A, B is 8 and C is 16, right? In C, B is 10 and C is 25. I'm looking at the numbers in the expanded form. I'm not looking at the binomials. I'm asking you to think about what I'm saying by looking only at the simplified form. Over here, B is -6, C is 9. Over here, B is -24, C is 144. And there's a relationship here. And I could have stopped here. And I know that if I said to you, what's the relationship between B and C? Many of you would have said, well, C is twice as big as B. I double B to get C. And that's true, but that's not true for all of them. So what I am asking is this, and I'm going to go back to what you're looking at on paper. I am asking you, what do you do to 8 to get 16? And it's the same thing that you do to 10 to get 25. And it's the same thing that you do to -6 to get +9. And it's the same thing you do to -24 to get +144. I don't want to know the answer just yet. I want everybody to percolate on that mentally. And we'll do the same thing I've asked you a few times. Put your hand up and then down if you know the answer. And if you don't yet, keep thinking about it. How many of you now know the answer and you didn't last time I asked? I mean, if you can't figure it out on your own, that's fine. But when I tell you what the answer is, you better remember it. Jack, do you know?
C is equal to B divided by 2 squared.
Right. And you don't mean B divided by 2 squared. You mean B divided by 2 squared. The square of half of B equals C. So if we look at A, the value of B that we get in the trinomial is 8. As Jack said, if you take 8 and divide it by 2, that gives you 4. And when you square 4, you get 16. When we take a look at b, you have negative 6. Well, half of negative 6 is negative 3. And when you square negative 3, you get positive 9. In C, half of 10 is 5. When you square 5, you get 25. Half of negative 24 is negative 12. When I square negative 12, I get 144. So this is very important. If I told you this is where this is going, if I told you that this is a perfect square trinomial, but I didn't tell you the constant term, you should be able to figure out the constant term. You would take negative 20 and divide it by 2 and get, you would take negative 40 and divide it by 2 and get negative 20, and you would square that and get 400. If I said we had x squared plus 14x plus a number, and this was a perfect square trinomial, I want everybody right now to figure out the number that must be if this is a perfect square trinomial. It's 49, right? Half of 14 is 7. 7 squared is 49. So let's turn the page now. In a perfect square binomial of that form, now I realize here I have a typing mistake. That should say in a perfect square trinomial, because it's already expanded out. In a perfect square trinomial of the form x squared plus bx plus c, please make a note that it's 1x squared. It only works if it's 1x squared. If you take the square of half of b, you get the value of c. We're going to use this to convert from standard to vertex form today. And this is called completing the square. So when you go from ax squared plus bx plus c to a times x minus p squared plus q, you are completing the square. I want you to notice something. This is a perfect square, isn't it? Because it's x minus p squared, which means when you expand it out, the constant term has to be the square of half of the coefficient of x. That's how we create a perfect square. So now we can get to the examples, and there is another typing mistake here I noticed, and it's actually in your notes. It says, convert each of the following quadratic functions, and it says to standard form. They are in standard form. We are converting them to vertex form. So here we go. We're doing 4 of these, and that's it. That's what we're doing today. Let me ask you a question. Is this a perfect square trinomial? Nope, because half of 10 is 5, and 5 squared is 25. But the vertex form contains a perfect square. So here's how we're going to do this. It's pretty crafty. We're going to rewrite this as y equals x squared plus 10x. And we're going to take that 16 and we're going to move it over here. We're not going to forget about it. We're just going to nudge it out of the way. What we want is to make this a perfect square trinomial. Because if we can make that a perfect square trinomial, and this is subtle, but if we can make it a perfect square trinomial, then we can write it as a binomial squared. And that's exactly what's in the vertex form, a binomial squared. So I want you to figure out what number, and we've already mentioned the number, but go ahead and figure out what number would have to be here to make that a perfect square. 25, right? Half of 10 is 5. 5 squared is 25. And I'm going to write something on the board that I'm only going to write once or twice. We are thinking for this. We are taking 10, we're dividing it by 2, and we're squaring it. So we're getting 5 squared, which is 25. I'm not going to write that every time. If it's a written response, you should write it. Okay, let me ask you a question now, though. Is this function the same as the function we started off with? Well, no, I've added 25. It's different. How can I make it the same but keep that 25 there? Let's do that. I'm going to add 25 to that one part of it to make it a perfect square. And then I've upset the balance here. I've added something to the right-hand side. It's no longer balanced. I'm going to take 25 away, but I'm going to do it someplace else on that side. And I hope you would agree that if you simplified this by taking 25 plus 16 minus 25, you'd be back at the beginning, wouldn't you? But we're not going to simplify it. We're going to write this as y equals a binomial squared minus 9. Is 16 minus 25 9? Yeah. Now the question, now we have to think backwards. What binomial would you square to get x squared plus 10x plus 25? Yep.
X plus 5.
X plus 5. Can you tell me why you know the number here, Jack, is 5?
Because you would have to double 5 to get 10x.
Right. This is really important. This is, you may not think this is important because some of you might just go, well, this is 5 because the square root of 25 is 5. And that's partly true. But the reason it's plus 5 is that half of 10 is the 5. Or to put it the way Jack did, you'd have to double 5 to get 10. So this is it. And what I'm really interested in today, I just didn't have time to change my notes, is I'm interested in this. I don't care about the graph. Okay? I really don't. But now we know that P is negative 5, Q is negative 9, and A is 1. We now know everything there is to know about this function. Remember on day 2, the beginning of day 2, it might have even been in a seminar after our first class, I gave you all a quiz where I gave you something like this, and you had to fill in the blanks and say, where's the vertex? What's the axis of symmetry? What's the domain? What's the range? Is there a maximum or a minimum? What is it? Where does it occur? Well, you can answer all that now. The vertex is at negative 5, 9. The parabola opens upward. The minimum value of y is negative 9. The axis of symmetry is at x equals negative 5. Do you get my drift here? That we already know how to do all this. So could you sketch a graph of this? Yeah. But I don't want us to spend class time doing it. I want us to focus on the algebra. Quickly though, I suppose we could check by graphing in our graphing calculator the original function, y equals x squared plus 10x plus 16 try zoom 6. There's the parabola. Does it open upwards? Yes. If a is 1, then this parabola should have the same shape as y equals x squared, and it does. The vertex should be at negative 5, 9. Lots of ways you could figure that out. I think the table is maybe the best way to do it. Oh, I guess that doesn't really tell me that it's the vertex, though. I guess we would have to go minimum, put our cursor to the left. By the way, I don't know that we've encountered this. I've got two graphs on there, and I've went to the calculate menu. In order to switch from one graph to the other, you toggle up or down. So if I happen to be on the wrong graph, I just use the up or the down arrow to toggle. Hit enter, scroll to the right of the minimum, hit enter, -5, -9. In other words, I'm not lying to you here. I'm not teaching you something that's wrong. Let's try another one. X squared minus 6x minus 20. Your first step is to just bump that constant term out of the way. Don't forget about it. It's still there, but we want to ignore it just for a minute. And now we say, what would I add to this to make this a perfect square? And I'm not going to write this perfect square thing with the green bracket every time. Sooner or later, we have to kind of branch out on our own. The answer is 9, because half of -6 is -3, and when I square -3, I get 9. So a 9 goes here because that's what we're doing. We're taking half of b and then squaring it. You will always be adding a positive number, because when you square half of b, it will become positive. In our next step, we're going to write y equals x minus 3 quantity squared, because as Jack said, -3 is the number that you double to get -6. But I didn't finish the step above. There's one more thing I have to do in the step above. Butesha, can you tell us?
For what, sorry?
What did I forget to do up here in this line? Something else I need to do. Right, I got to do my correction. I messed with the equation by going +9. I got to fix that. And you don't fix it by just erasing it, because then you're back at the beginning. You fix it by subtracting 9. So that means it will be x minus 3 quantity squared minus 29. P equals 3. Q equals -29. A equals 1. If it were that simple, then it would be really simple. Of course, it's going to get more difficult. It gets a little bit more difficult today and then a lot more difficult tomorrow, because in this question, we have y equals 3x squared minus 18x plus 20. And this is really, really important. If you look at page 1 of this lesson, you don't have to. I'll go back and I will show you. Page 1 of this lesson, all of these perfect square trinomials had 1x squared. And the reason they had 1x squared is because in the vertex form, we are squaring this, and this will give you 1x squared. That perfect square trinomial will never have a coefficient other than 1. It can't. So before we add this number, we got to arrange it so it's 1x squared. And I don't mean let's just erase the 3 and write 1. It's not how math works. But we can make this coefficient in front of the x squared 1 by factoring 3 out. If I factor 3 out of 3x squared, I'm left with x squared. If I factor 3 out of -18x, I'm left with -6x. I don't factor the 3 out of the 20 because the 20 is not part of this little game of the perfect square. Now I say, what do I add here to make this a perfect square? And the answer is 9. Yes? Half of negative 6 is negative 3. Negative 3 quantity squared is 9. Now I got to do a correction, don't I? What should I do over here with the 20? No, you don't take away 9 because I didn't add 9. I haven't lost my mind. Well, in this particular instance, I have not lost my mind. I did not add 9 to the right side of the equation. What did I add to the right side of the equation? So I can tell almost everybody's going, yeah, I think he has lost his mind. I didn't add 9. Do you know what I added, Zoe? No? I wrote 9. I added 27. Because there's a 3 outside that set of brackets. This is what I've added. I have added the 3 times the 9. I've added 27 to the right side of the equation. So I have to take away 27. Because that perfect square trinomial is being multiplied by that 3 that I factored out. The number that I add inside of the brackets has to be multiplied by that 3. So I've written plus 9, but I've written plus 9 in brackets that's being multiplied by 3. So I've added 27. And now we're pretty much done. This will be y equals 3 times x minus 3 quantity squared. The number here will always be half of the number here. And then 20 minus 27 is negative 7. So we have p equals 3, q equals negative 7, and a is equal to 3. And again, from that, you could tell me everything there is to know about this parabolic function or this quadratic function. By the way, if you take this, and this is very easy to trace. If I said simplify this bottom line, you would start by taking x minus 3 times x minus 3, and you would get this. Whoops. You would start by taking x minus 3 times x minus 3, and you would get that. Then you would multiply that all by 3, and you would get 3x squared minus 18x, and you would get 27 minus 27 plus 20. You would get that 20. Let's try one more. So y is equal to, I call this first step just prepping my workspace. You may not think it's a big deal, and many of you will want to do the first step at the same time. But my experience says if you try to do too much at once here, you get an incorrect answer. So, I cannot start worrying about what to add to make this a perfect square trinomial because the coefficient of the x squared is not 1. To make it 1, I factor the negative 2 out. When I take negative 2 out of negative 16, what does that mean? It means I divide negative 16 by negative 2. I get positive 8. Now, positive 8x. Now I can worry about what to add there. I still have my plus 4. So what do I add inside of the brackets to make that a perfect square trinomial? 16. Half of h is 4. 4 squared gives you 16. Perfect. So I go plus 16. Now I have written plus 16. That doesn't mean I've added 16. In fact, I haven't added anything at all here. I've really subtracted 32. Because if I take this number and this number and multiply them, why am I multiplying them? Well, I'm multiplying them because if I were to expand this out, I would have to multiply that -2 by everything, including the 16. So by me writing 16, I've really added -32 or taken away 32. And the key idea here, no matter how you think of it, is you do the opposite outside. And if we put -32 on the right side, then we have to put +32 on the right side to even the score. Which gives us y equals -2 times x plus 4 quantity squared plus 36. So a is -2, p is -4, q is 36. Any questions with that final example? Tomorrow is our seminar day. Tomorrow we're going to have a quiz on this, on completing the square. So this is what you have to be able to do. You have to be able to take, well, that's awfully bold writing. You have to be able to take in any of these ones that are listed as practice, the standard form and convert it into vertex form. And you need to be able to do it on paper. Just for kicks, it's not wasting your time. I want to go back to the question about cost that we did. Could we have used what we now know about completing the square to turn this into vertex form to see where this minimum point is? Well, sure. You would start by prepping this function and nudging the constant term out of the way. Then you would factor out 75 out of the n squared and the 1800n, and I'm convinced that 75 divides into 1800 an integral number of times, and I want to say 72. But I'm obviously wrong. I want to know what 1800 divided by 75 is. 24. Boy, was I ever wrong. 24. N. Plus some number I'm going to add. Then I have plus 60,000. Figure out for me, and you might need a calculator here, what we add. 144. Half of -24 is -12. Squared is 144. Figure out what we have to subtract outside of the brackets for me, please. And I'm willing to bet you will need your calculator here. $78,300? Nope, obviously not. I'm off my game for math here. Will, can you tell me what we get?
I got
10,800. And just checking here, you're multiplying the 75 by the 144. Okay, boy, was I ever off. I better not do any more calculations this afternoon in my head. I'll maybe try this one. So When I write this in completed square form, I have a 75 here. By the way, I hope you understand the 75 has nothing whatsoever to do with the answer to this question, other than the fact that the parabola opens up. Will be x minus 12 squared plus, don't tell me, 49,200. So the vertex, which is a minimum point, happens when n is 12 and gives you 49,200 in cost. You didn't have to use a calculator at all. Well, for graphing you didn't. And some of you are going to prefer that. I know I do. I hate having to go to your window settings and change all of that stuff. And I can tell many of you do as well. So, yeah, make sure you know how to complete the square for tomorrow. In the seminar, we'll go over a few questions, and maybe the last 10, 12 minutes of the seminar, we'll have a quick quiz. I suspect I'm going to give you 2 to complete the square.